Hi, welcome to Module 10. This is about the issues in software development. So in the previous module, we basically spoke about the types of software development structure. We talked about different languages. We talked a little bit about software development and the processes. Now what I want to do is I want to kind of just touch on some of the issues. And then in 10.2, we're going to talk about beyond software development. We're going to talk about things that need to occur after the thing is developed or even during the process of development. But that little slice of development is just one piece of the overall software development lifecycle. Here's a problem. This is a great little chart that basically shows how the customer explained what they want, how the project leader understood it, how the analyst ultimately designed it, all the way to what the customer really needed. I love this one, how the project was documented, because there is no documentation. The funny part to this is it's really true. And it's not a laughing matter. Human beings generally tend to love to communicate, but they tend to communicate and then they put their own biases or their own spin on it. And so things aren't necessarily as clear as they should be. And this causes a problem in complex projects, especially when you're trying to get people on from different domains. That means software developers who understand code and say finance people or marketing people who understand finance or marketing. They're not speaking the same language, which is really why people like enterprise architects or architects in general, solutions architects, technical architects, are really important because they should be able to bridge the gap between the two. Your business analysts should be able to do the same thing, and hopefully that minimizes some of this problem. The IS department is really in three businesses. Operations deals with infrastructure management. The help desk is all about customer relationship. Application development is product innovation, product deployment. Really, the goals are different, and this is where the crux of an IT problem lies, is operations focuses on reducing costs, but on the other side, application development focuses on creativity and time to market. Those two are sometimes mutually exclusive. Not always, but sometimes they are. And when the application development and the operations group do not get along or do not see eye to eye, these types of goal differentials become very, very problematic, especially for CIOs. That's why good leadership will understand how to manage this appropriately. The focus in operations is efficiency. The focus on application development is innovation and ROI. Now, that's not to say application development is always good at determining ROI. They just want to basically push out code or push out new products. And sometimes both at the expense of the business and at the expense of operations. And operations may not want to put things in because it presents a risk to the environment. And their goal is really to manage risk. Sitting in the middle of this is the help desk. Once something goes into play, they want to provide service and they have a customer focus. So they're trying to help the business. And technically that may not be in the interest of operations or application development. They have different goals and they basically serve different masters, if you will. Project management, I'll spend a little bit of time on this. Basically, this is all about managing a project. The thing I want to get to is IT project management is not much different than other forms of project management. But the only exception is it's good to have a project manager who understands the terminology and understands some of the basic tenets of software development. If you have someone who's managing a project for building a road or a construction, it's more than just lines on a spreadsheet or lines on a Gantt chart or a PERT chart or AOA diagrams. You want them to have an understanding for what goes on. The reality is that ultimately you have to get the job done. It has to be dealt with in terms of the time and the budget. And those are two principles regardless of whether we're talking an IT-related project or a non-IT-related project. Good project managers will know how to manage the resources effectively, manage the risks, and manage all the other pieces, but not necessarily having to know everything about development. But it's good when they know a little bit about the development. They should know all the pieces, though. The project lifecycle, and this is a simplified version, can be broken down into 4 pieces: initiating, planning, execution, and closing. And what we can do is we can separate this more because the actual software development lifecycle has 7 phases to it. But I wanted to simplify this a little bit because this is a little bit easier to understand. We manage across all of these things, and this is our project management line. And we have what's called a solution delivery. At each level, we're looking at the solution to ensure that it's meeting the needs of the business. And so the project manager has to make sure that all the items are occurring on time and on budget, and that it's ultimately meeting the needs of the business. It's identifying the risks and identifying any gaps that may need to be remediated at a later time. Project management encompasses 5 processes: initiating, planning, executing, controlling, and closing. with 9 knowledge areas: integration, scope, time, cost, quality, the actual human resources, communication, risk, and procurement. Now, I'm not going to go into all of these, but basically, this is fairly reasonable and fairly obvious. We initiate, we plan, we execute, which is our development, we control the actual implementation, and then we close. We monitor at the back end. The 9 knowledge areas are all about how are we integrating with the individual departments, what's the scope of what we're going to do. This is the big one: scope, time, and cost. These three, number 2, 3, and 4, form what's called the resource triangle. And one of the fundamental problems, especially in IT projects, is that people want to change the scope. But if you change the scope, ultimately you're going to have to either change the time or you're going to have to change the cost. In other words, you can get 2 out of the 3, but you can't get all 3. And what that means is I can do things fast and I can do things cheap, but that means you may not get all the scope you want, or you may not even get the quality. If you want a lot of scope, I can't necessarily do it fast if you want me to do it cheap. And so it forms this whole notion of the resource triangle, and it's something else that you can look up. Some of the other pieces we'll actually touch upon as we move forward. Who's responsible for setting up the task? Number 1 is setting up the project. Why do we want to do this? What exactly are we going to do? What are the high-level plans? Who's doing what? And how is it going to be done? All these are basically just a piece of paper. It's a document that basically dictates how we're going to function. Number 2, we manage the schedule. Basically, we'll create some sort of project plan. We'll use that as a communication vehicle. We may actually discuss things on a regular basis, twice a week or once a week or maybe once every 2 weeks. And what we'll do is we'll keep a baseline. We'll track to that baseline. Are we on target for meeting our deliverables? Do we have to make any changes? Sometimes, and I've seen this, I've seen a project plan that was 2-3 years out with 25,000 lines. And one of the comments that I made, and this was a very large company that did this, was anyone who believes they can manage to the letter a 25,000 line project plan is either arrogant or incompetent, because things change over time. People have vacations. You may have a disaster on your hands where you have a strike or you're no longer allowed to use the building, like a natural disaster, say Sandy. Things change. It really serves as a guideline, and that's ultimately what you want a project plan to do. Serve as the guideline to make sure that you're on track. Managing the finances. A lot of times you get these budget overruns, mostly because of a failure to manage scope creep. We want more in the functionality than we really paid for. And what some business users do is they will actually agree upon a scope at the beginning and then try and change it later on because they don't have the budget to actually ask for it in the beginning. So they try and coerce and say, well, we can't really use this without this, without this functionality. But this functionality is going to cost an extra $50,000. Well, you have to find it, otherwise we're not going to be able to use the system at all. So now IT is sometimes caught in a little bit of a quagmire, but again, that's for management to deal with. Managing the benefits. A lot of times we want to make sure that people who say we're going to get a return, that you actually get the return. In many cases, that's not the case. You don't get the return because it wasn't clearly estimated properly. So you'll have a marketing department say that we have a $1 million return on investment in the first year, and later on you get nowhere near that. That's an accountability factor, but that falls into project management as well to ensure that how did you come up with the numbers. Managing risks, opportunities, and threats. This is the biggest one. It's usually poorly done. We fail to identify all the risks that could hit the project. Some people go overboard on it, and I actually tend to think that I like to be on that side. I'd like to go a little bit overboard, not tremendously overboard, but I'd like to think of the risks as being very important. And then if I go overboard, I'll consider them very low probability risks, but at least they're on paper, and at least they've been identified. Because again, if something can go wrong, it will, and it usually does. And then independent reviews might be healthy checks. One example of this might be if you do an independent audit from a security perspective. You don't want your internal people necessarily doing that. Another example might be an independent audit of quality. So before it goes into production, you want to make sure that it's living up to the quality that it's supposed to.